Chemical properties. In the chemical property, we will see the chemical reactions of alcohols. The first category of the reactions shown by the alcohols are the reactions involving the cleavage of the OH bond. So only the H of the alcohols will move out, whereas the R and the O will remain the same. The whole of the molecular species, the alkyl group and the oxygen will remain as such, and the H will move out. Now this means we are trying to study what? Their acidic reactions. So we are trying to study their acidic nature. The first reaction in this category is reaction with metals. Mainly we will be dealing with reactive metals. When any alcohol is reacted with the metal like sodium, what happens is sodium, being more electropositive, replaces the hydrogen of the alcohols, and what we get is sodium alkoxide and hydrogen. This hydrogen is given out with popping sound, and it is also taken as one of the tests to check the presence of the OH group. And that is why this reaction is also shown by carboxylic acids, because they also have one OH group. So the reactive metals are able to replace this hydrogen, and this leads to the formation of the alkoxides. Similarly, like let us take the example of CH3CH2OH, ethanol we are having. When it is reacted with sodium, what we get is sodium ethoxide and hydrogen gas. So the compound which we have got is sodium ethoxide. Then now let us see the other one. They can react with more reactive metals, like the other reactive metals, like if we are having, suppose, isopropyl alcohol with aluminium, what it forms is aluminium isopropoxide and hydrogen gas. So this is how they can react. This same reaction is also shown by phenol, where it forms sodium phenoxide and hydrogen gas is released. Even more interesting to note is that we can take it as a second reaction with alkalis. Yes, alcohols doesn't react with alkalis like NaOH, but the moment we take phenol and we react them with alkalis like NaOH or KOH, what we get is potassium, like in this case potassium phenoxide and water. So this shows that phenols are more acidic than alcohols, and alcohols are acidic, but they are not very good or strong at they are bases basically. They are acting as like the acids, but they are not very strong acids, because if they are actually a good enough acid, they could have reacted with these alkalis and they have resulted in the formation of the salts. But no, this is not happening. That's why we can clearly say that phenols are more acidic than the alcohols, and that is which is because that they are able to react with the alkalis and results in the formation of the phenoxides. So these are the reactions which are clearly showing that they are acidic in nature. Now let us compare the acidic natures of the alcohols and phenol. Now let us compare the acidity of alcohols and phenol. What we find is, when we take any alcohol, we know that it breaks down into alkoxide and releases H plus ions if it is acting as an acid, and the dissociation constant of this acid is found to be between 10 to the power minus 16 to 10 to the power minus 18, which is a very small value. Whereas in a very similar way, we can say the water also dissociates to form hydroxyl ion and H plus ions, and its equilibrium constant called ionic product of water we know is 10 to the power minus 14. And if we take in a very similar way the phenol, which breaks down into what? Phenoxide ion and H plus ion, what we find is its K is 10 to the power minus 8 to 10 to the power minus 10. Now this shows that these dissociation constants values shows that the acidic nature of alcohols is least, water is more acidic than alcohol, and the phenol is more acidic than these alcohols and water. So alcohol out of the three is the most acidic, followed by water and then alcohols. Now the question comes is, why the alcohols are less acidic than water? Now the alcohols are less acidic than water, it is because of the what? The plus I effect of the R group. See, in alcohols what we find is this R, due to its plus I effect, increases electron density on this oxygen. Therefore this oxygen has lesser tendency to withdraw electron from the hydrogen, so it is what? Less acidic. Whereas we have no such plus I effect in water, therefore it is more acidic. That's the major reason. Now what makes phenol most acidic out of the three is a reason. Let me tell you in this way. See, in phenol what we find is the OH group shows what? This type of resonance, which is called plus R effect. Now this charge will move around and then it will again go back to the oxygen. Now due to this plus R effect, the oxygen acquires what? Positive charge. It becomes electron deficient. Therefore it will be able to withdraw the electron from the hydrogens very easily, and that is why what we find is this increases the acidic nature of the phenol. There is one more reason. Now because of this, the conjugate base which we get called phenoxide ion. So this phenoxide ion is resonatingly stabilized. We know from the class 11th Lee-Chatler's principle, or we know from the Bronsted-Arrhenius concept, what? That more stable is the conjugate what? Base, stronger is the acid. And what makes this conjugate base phenoxide ion very stable is this what? R effect, plus R effect. And the oxygen is having an extra pair which is being easily transferred to the benzene ring. That is why phenol is much more acidic than what water and the alcohols are. Now what is again interesting to note, next thing is, what are the effects of the substitutions on phenol, acidity of phenol? Now let us discuss the effect of substitutions. Substitutions on acidic nature of alcohols and phenol. See, it's very clear. Electron withdrawing groups, due to their what? Minus R and minus M. Minus R or minus M decreases electron density on oxygen atom of OH group, therefore increases acidic nature. And electron releasing groups, due to their plus R or plus I, increases electron density on oxygen atom of OH group, therefore decreases acidic nature. That's the most basic thing. Now let us discuss this with some examples. Like if we compare the acidic nature of the alcohols, this is N butyl alcohol we have. This we can have is secondary butyl alcohol, and if we compare this with tert butyl alcohol, what we find is this is in this order. What will happen is it will be the decreasing trend, it will be like this. So the most acidic out of the three will be which one is your this IN1, because here we are getting plus I only from one side, whereas the secondary's plus I is much more powerful, whereas tertiary's plus I is the most. So what we find is out of the three, what we find is the most acidic, which is increasing, the most acidic will be out of the three will be this one, the primary one. That is why what we find is the tertiary ones are least acidic in their nature. The reason being the plus I increases this electron density on this oxygen enormously. So that is why the OH is released to the least extent out of these. And then let us now see in case of phenol. What we find is, like if we compare